So in this session, we like to understand the terminologies joint probability and marginal probabilities. When we talk about a measurement, let's say for example, height of a student body, that's one measurement. And so we always measure height of a given um, item, in this case, a student. But we don't only have to measure height, we can measure height and weight, and of course many other attributes of the particular student. So if we measure height and weight, then we will have x and y, right? So we would have two uh, numerical quantities or even descriptive qualities like gender and exercise preference, for example, right? So we can always have two measurements. Just think of x and y as two measurements, two sets of measurements. And we would like to explore the joint probability. That is, how likely is it that a person is of tall height, let's say greater than 180 cm, and heavy weight, y is greater than 100 kg, let's say. All right, so that would form one event. So this and that forms one event. The way we say it is the joint probability of tall people and heavy people, or in a smoother description, it will be the probability of a person being tall and heavy. Now, where we quantify more specifically what is tall, what is heavy. So here in this example, we like to talk about the joint probability of x and y, where x takes up the attributes: does a person have Visa card or not Visa card? All right, you may have American Express, you may have many Diners Club credit card or many other credit cards, but no Visa means you belong to no Visa category, right? And of course, the Y will measure another qualitative measure. Does the person have MasterCard versus the person does not have MasterCard? So that is a joint probability because we can ask a particular measuring item. That means a person. Do you have a Visa card? Do you have MasterCard? Right. So um, if out of 10, let's see, seven, yeah, if out of 10 people, we have 3 people who have Visa card and MasterCard, we would record as 3, but divided by 10, so that's 0.3 relative frequency, right? So uh, joint nothing, right? Joint table of x and y can mean relative frequency of these two occurrences, or if we call it joint probabilities of x and y, then it has to be, yeah, probability. That means it has to be a forward projecting kind of likelihood measure of the two events happening at the same time. For example, like a person holding both Visa and Master at the same time. So in the past, we asked 10 people, and let's say 4 people said they carry MasterCard but no Visa. And so we record as 0.4. That's factual, right? But if we declare that into the future, actually, you know what? I would assume, I would assert, I would state without proof that in future, maybe the near future, any random person that I ask is going to have a 0.4 probability of holding on to some form of a MasterCard, but no Visa card at all. You see that, right? So that's how we use past data to guide us into the future. Yeah. So relative frequency, probability. So we covered that, right? So about joint table. So here the table can either be of the past relative frequency or the future probabilities, right? So joint table of x and y. So that's called a joint table. Now the joint table actually covers only everything except the pink columns, the protruding pink columns here, right? So the joint table does not uh, technically include these, although we may write them by the side. And these are called marginal probabilities because they are written at the margin. We would call side, right? We might even call it at the, near to the side of the fringe of the table. We might call them fringe probabilities. So again, don't let the word marginal affect your understanding as if they were incremental or something different. No, they are still just probabilities. They must add up to 1. They must be non-negative, right? Except marginal probabilities are formed when we are talking about it in the context of a joint probability table like this. So in the context of a joint probability table, we first begin by having a joint probability table like this. And then we add them up to get a 0.7, right? So we kind of like y equals to master. And regardless of x, whether x is visa or no visa, we add across, right? So we add across all possible values of x and thereby ignoring x, all right? So whenever y is master, regardless of x, the probability of a person holding on to a MasterCard, regardless of whether you have Visa or no Visa, is going to be 0.7, which is quite telling because it means that in this case, if it's actually a market study, that means MasterCard currently has the sort of dominant market share, right? No master, therefore, is 1 minus, but we can check again. 0.1 plus 0.2 gets us 0.3. Similarly, we can form the marginal probabilities of P of x equals to x, right? So it is whenever x equals to Visa, then for all values of y, regardless, we can say regardless of y, but you can also say for all values of y equals to master, no master, add up all the probabilities and you get a 0.4. Same thing, whenever x equals to no Visa, then we add up all possible joint probabilities, right, of y equals to master, y equals to no master, and we get 0.6. Now, a bit of a terminologies. The beige colored numbers here, these are the joint probabilities of x equals to certain value, y equals to certain value. Okay, at the fringe here, these are called the marginal probabilities, of course, relative to the presence of the joint table here. The marginal probabilities are just involving one variable. I put a comma here means I'm talking about two marginal probabilities, right? So if you look at P of x equals to Visa, P of x equals to no Visa, that's just the usual probability. The count of x equals to Visa, count of y equals to, count of x equals to no Visa, right? So marginal probabilities is just our original understanding of the basic definition of probabilities, except again, it is spoken about. We use the word marginal whenever we are talking about it in the context of a joint distribution. All right. So if you talk to me like, what's the probability of a person having Visa? P of x equals to Visa. If you just say like this, I'm imagining that you are doing a market study, right? Just to collect information about people whether they have Visa or no Visa. But if you say it as the marginal probability of x equals to Visa is this and this, then not only that I'm understanding you in the sense that you are doing a study of people having Visa or not Visa, I'm also additionally getting the information that you are doing this as part of a grander study of the joint uh, uh, probability of X having Visa, no Visa versus something else. And of course, you then tell me, what is it? Is it American Express? Is it MasterCard? Is it Diners Club? And all that. Yeah. So joint probability X and Y. Now, actually, you can also have more measurements, but let's just stick with more than one, right? So X and Y. So when we extract the marginal probabilities and write them out like this, they appear completely like any normal, the commonly found probability descriptions that is already quite familiar to us, right? So no difference except we use the word marginal when we want to describe it in the presence of a joint probability table. Now, when we talk about a table like this, we ask, is this independent or not, right? So that is another question. We ask, is this a population or not? That is yet another question, right? So just very quickly, is a table here a population or a sample? Now, if you are recording this as a joint table of relative frequencies, then that table can be either population or sample, because you may be expanding your sample the size is not yet fixed. But if you are talking about it as probabilities, then this table necessarily will have to be a distribution, will have to be a population. Okay, and in other words, you are declaring that you know for sure all the possible measurements into the future. Of course, that is in reality not going to be possible, but that is theoretical guidance, right? So we assume we know all the measurements in the population when we declare that this relative frequency joint table is a probability joint table. Okay, so let me rephrase it. Whenever a question posed to you and say, referring to this joint probability of x and y as shown below, and then they show you this table, what they imply is that that is the population. What is important here is because if they ask you to start calculating variance, sample variance, population variance, that means you got to decide: is do I have to use the population variance formula or sample variance formula, right? So again, this this distinction is implied. If you call this joint probability table, it has to be a population. But if it's not, then the question better clarify. Is it about a collection of samples, but I'm presenting to you in a tabular form? Or am I saying that that's it? That's it. I've examined all items in the population that I'm interested in, right? So the question will have to clarify otherwise. Clear? All right. So that is how the communication is being done.